Hi everyone, this is Mrs. V Chen. Welcome to my Form 2 Math lesson number 15. Today is 3rd of May 2020. Alright, so today's topic is about special angles. Now here we have a table for special angles. So we have 0 degree, and then 30 degree, 45 degree, 60 degree, and 90 degree. So what is the value of sine theta when theta is equal to 0? So the answer is also 0. Alright, and then what is the value of sine 90 if theta is 90 degree? So the answer is 1. Okay, so you can see that from 0 to 90, for the value of sine theta, actually it is getting bigger and bigger starting from 0 to 1. Okay, so we can use calculator to check the value. Let's say, what is the value of sine 0? So you can see the answer is also 0. And what is the value of sine 90? So which is same as 1, is that right? Okay, so, and then what about 30 degree, 45, and 60? So for sine, we always have this divided by 2, divided by 2. Okay, and since sine theta, it is increasing in this way, so that we have this 1, and this is root 2, and this is root 3. Okay, if you follow this pattern, I think it would be easier for us to remember the value of sine for these special angles. Okay, next we come to cosine. And then what is cosine 0? I use calculator, so cosine 0, which is 1. Alright, so what about cosine 90? I use calculator, cosine 90, which is equal to 0. Okay, so that you can see for cosine, when this is 0 and going up to 90, the value actually is decreasing. So that we can use this pattern to remember the value of special angles for cosine. This is also over 2, and then over 2, and over 2. Alright, so since this is getting smaller, so we start with root 3, and this is root 2, and therefore this is 1. Okay, so is that easier for us to remember these special angles in this way if you follow the pattern? Okay, now we come to the value of tangent theta, so that this identity is very important. So I have to give you this information about tangent theta is always the same as sine theta over cosine theta. So what about tangent 0 here, which is same as sine 0 over cosine 0 degree, so which is 0 over 1. So what is 0 over 1? Which is infinity. Alright, so that is first one. Okay, and then what about tangent 90 here? So tangent 90 is same as sine 90 over cosine 90, so that would be 1 over 0. So 1 over 0 is 0. Alright, so how about tangent 45? So 45 is the kind of special angles as well here. So tangent 45, according to the identity, which is same as sine 45 over cosine 45. And then let's look at that. So what is the value of sine 45, which is root 2 over 2? And then cosine 45 is also root 2 over 2. So when you have the same numerator and denominator, so therefore we say that tangent 45 is equal to 1. So that this is equal to 1. And then you can check with your calculator what is tangent 45. See? Which is equal to 1. Okay, so next we come to 30 degrees. So how about tangent 30? Tangent 30 is same as sine 30 over cosine 30, and sine 30 is 1 over 2. Okay, and then over, same as divided by root 3 over 2, that is the value of cosine 30. So that I simplify this using this way. So to flip over this, so that is 2, that is root 3. Therefore, I have this cancel out. So that would be 1 over root 3. So tangent 30 is equal to 1 over root 3. Okay, so finally we have this tangent 60. So that here we have this identity, tangent 60 is equal to sine 60 over cosine 60. So what is value for sine 60? Which is root 3 over 2 divided by times. Okay, I just flip over this. I put 2 up and then 1 here, and then if you cancel out that, so tangent 60 actually is same as root 3, so that I put root 3 here. Okay, so therefore in today's topic about special angles, we are going to find this sine, cosine, tangents for these special angles without using calculator. So once again, look at sine. Sine is getting bigger in this way, and then cosine is getting smaller. All right, and then for tangent theta, we need this identity, saying that tangent theta is always the same as sine theta over cosine theta. Okay, so let's do some exercise. This time without using calculator, we have to find the value of each of the following expressions. So here, the first one, 4 cosine 45 and then sine 45. So what is meaning 4 cosine 45? It means 4 times cosine 45 and then times sine 45. All right, so times. All right, so what is cosine 45? Which is root 2 over 2, and then how about sine 45, which is also root 2 over 2? Okay, so therefore it is very important that you have to memorize these special angles in this table. And then we have sine 45, root 2 over 2, cosine 45, also root 2 over 2. Okay, therefore we can simplify. So 4 and then here 2 cancel out, right? So root 2 times root 2, the answer is 2. Okay, so next we have sine 30, cosine 60 means times, and then plus tangent 45. All right, so what is sine 30? Sine 30 is 1 over 2, and then times. What is cosine 60? Also 1 over 2, and then plus. What is tangent 45? Which is 1. So again, what is important, this table is very, very important, so make sure that you can memorize all these values for the special angle. So we have sine 30, 1 over 2, and then cosine 60 is also 1 over 2, and tangent 45, which is equal to 1. Okay, so therefore you can simplify. So this will be 1 over 4 plus 1, okay, and then 4, and then this is 1. So, and then you make it into 4 pieces, so it will be 1 plus 4, which is 5. So this is the final answer for example 1b. Okay, so next one we have cosine square 30 and then divided by 3 tangent 45. Okay, so actually what is meaning of this square? It means we have the whole thing, which is square in this way. So what is the value of cosine 30, which is root 3 over 2? All right, and then now we come to this one, denominator. So 3 times tangent 45 is 1. Okay, all right, so therefore for this part, so this is all square, so that would be 3. Root 3 square is 3 over 4 times here. So divided by 3 is same as 1 over 3. Okay, so finally the answer will be 3 and 3 cancel out. The final answer will be 1 over 4. All right, so what is meaning of cosine square 30? It means the whole thing, cosine 30, or square in that way. Okay, next, this is tangent 60 times cosine 60. All right, and the bottom part here is 1 minus sine square 45. All right, so what is tangent 60, which is same as root 3, and then times, okay, cosine 60 is 1 over 2. All right, so we do it step by step, and then we come to 1 minus, okay, square here means the whole thing's here, square. All right, so what is sine 45, which is root 2 over 2. So once again, the table is very, very important. Okay, now I can do simplification. So for this part, so this is root 3 over 2. Okay, divided by the whole thing. Okay, I have 1 minus, so this is all square, so I have root 2 square is 2, and then 2 square is 4. Okay, therefore I have this root 3 over 2 divided by, okay, so what is value for this? Minus 2. Okay, so that will be root 3 over 2 times. I can flip over this. I put 4 on top, and then 4 minus 2 is 2. All right, so what is final answer for this? 2 times 2 and 4 cancel out. So final answer for this value is root 3. Okay, this is it. Okay, now we come to example 2. Also, we don't use calculator, but this time we have to find theta in each of the following equations. So part A, we have this root 2 sine theta equals to 1. So what will be the value for theta? Again, we do it step by step. The first thing we change subject to sine theta is equal to, so this is root 2, move to the right hand side, so that is 1 over root 2. Okay, so if I rationalize this, remember in the previous chapter, okay, so this is root 2, this is root 2, and then I can get rid of this irrational number here for root 2. So what is answer? So which is root 2 over 2. Okay, so therefore, obviously, what is value for theta when sine theta is equal to root 2 over 2? The answer is 45. All right, so this is how we don't use calculator. We can still find theta. All right, so because we have this special angles in this chapter. Okay, next one, we have this 3 root 3 tangent theta minus 3 equals to 3. So this is the equation given to us, and now we have to find the value for theta. Okay, the first thing, change subject to tangent theta, and then do it step by step. Okay, so therefore that would be 3 root 3 and then times tangent theta. I move this 3 to the right hand side. This is minus 3, so that would be plus 3. Okay, so this is 3 theta, and then tangent theta is equal to, so the whole thing here times, move to the right hand side, so that would be 3, and then over 3 with root 3, and then cancel out, so I have 1 over root 3. Therefore, what is the value of theta when tangent theta is equal to 1 over root 3? So the answer is 30 degrees. So once again, you can see this table for special angles is very, very important. So when we have tangent 30, the value is 1 over root 3. So the answer for theta here is 30. Okay, next, this is the equation. So tangent theta minus cosine 60 is equal to 1 over 2. All right, so this is the unknown here. So we have tangent theta minus. So what is cosine 60? Cosine 60 is also 1 over 2, equals to 1 over 2. And then tangent theta is equal to, so this is 1 over 2. Move this to the right hand side, plus 1 over 2. So this is equal to 1. Therefore, what is value for theta, which is 45. Okay, so how about this one? This is 7 over 3 plus sine theta equals to 2. Okay, so we can do this 2 move here times the whole thing, so that I will have 6 plus 2 sine theta is equal to 7. And then change subject to sine theta, so 2 sine theta, so do it step by step. Here we have 7, and then 6, move to the right hand side, so that will be 7 minus 6, which is 1, so that I have this sine theta is equal to 1 over 2. Okay, so what is theta? When theta is equal to 30 degrees, then which is equal to 1 over 2. So this is how we find theta by solving the equation step by step. Okay, next we have example 3 to find the unknowns. So here is the right angle triangle given to us, and this is right angle, this is 60, and the unknown here is x. All right, so which one we have to use, sine, cosine, or tangent? So okay, let us study first. So this is the longer side, we call that hypotenuse. Right, and how about x here? So x is right next to this angle, so therefore we call this adjacent side. Okay, now we have adjacent side and hypotenuse, so therefore we have to use cosine formula, so that we have cosine 60 is equal to adjacent side over hypotenuse. And then we have to solve for x. So therefore, how do we solve for x? So x will be equal to, okay, so that is 16 cosine 60. Okay, so 16 times, so what is 60? Cosine 60 is 1 over 2. So the answer for x is 8 in this way. Okay, so here is another diagram for B. All right, so the unknown is here, theta. Okay, but if you look at this triangle, so far we do not have enough information to find theta. So because we need this side first, so how do we find this side? We need to use this triangle to find this side. Okay, let's say I name this for x, for example. Okay, and then how do we find x here? So x, this is 45, so that this is 6 root 2 actually is the hypotenuse. All right, and then x to this angle is opposite. This is the opposite side. So first, to find x, I need to use this right angle and then using sine formula. So that would be sine 45 is equal to the opposite side is my x here over hypotenuse. So 6 root 2. Okay, so therefore what is x? X will be equal to 6 root 2 and then sine 45. So x is equal to 6 root 2, and then what is sine 45, which is root 2 over 2. Therefore, I have 6, and then root 2 times root 2 is 6 times 2 over 2. Okay, cancel out. So therefore, what is x? X is equal to 6. Okay, so that therefore this is equal to 6. Now I have enough information to find theta. Okay, let's study again. However, what about x? So what about x here to this angle? This time it is not. Yeah, which is also the opposite side. So this is the opposite side. This is the adjacent side to this theta. So this is adjacent side. Okay, and x is equal to 6, which is the opposite side. Therefore, to find theta, I can use tangents. So that would be tangent. Theta is equal to 6. So which is x as well over 6 root 3. Okay, so this is 6 and 6 cancel out. I have 1 over root 3. Therefore, what is the value for theta when tangent theta is equal to 1 over root 3? The answer is 30. Okay. Okay, so we do one difficult question which is in your textbook on page 52, exercise 11E. We have this question. And then since the picture is too small here, I enlarge it in this way. All right, so, and then what do we need to find is to find ratio of AB to AC. Okay, so here is the diagram. So AB is here, AC is here, we don't know. So how can we link them together? So we look at the common side. So actually AD is the common side. All right, so the first thing is, so this is in this triangle. Okay, I write it down first. So in triangle ABD. Okay, so AD actually is the common side for this angle, for this triangle, and then for this triangle. This is hypotenuse. AB is the hypotenuse, and this is the opposite side. Therefore, I can use sine 30 is equal to the opposite side, which is AD over AB. Okay, and then I can change subject to AB. So what is AB? Therefore, AB sine 30 is equal to AD. And then what is sine 30? Sine 30 is this 1 over 2 equals to AD. Therefore, AB is equal to, I move this to the right hand side, that would be 2AD. Okay, in that way. Okay, so now we come to the final question, which is on page 52, exercise 11E. You have this difficult question, and then you are given this diagram. All right, so this is too small, so here I redraw the diagram to enlarge it. Okay, so what do we need to find? A here is find AB to AC. Okay, so here I write again, we need to find AB, the ratio of AB to AC. Okay, now look at this triangle. So AB is here, AC is here, and then we don't know anything. We're only given 30 degrees and 60 degrees. So how do we find the ratio? So look at AD. AD is the common side for this triangle and then for this triangle. Okay, let's start, and then we look at this triangle. So let's say in triangle ABD. Okay, and this is AB. AB is hypotenuse and AD is the opposite side. So therefore I can use sine 30, which is equal to opposite side, which is my AD, over hypotenuse AB. Okay, and after that, I change subject to AB, so that would be AB sine 30 is equal to AD. Okay, and then AB times, what is sine 30? Sine 30 is 1 over 2. All right, so therefore, I change my subject to AB. So move this 2 to the right-hand side, that will be 2AD. Now, I get this AB in terms of AD. Okay, next, look at this triangle. AD is the common side. So now I put in triangle ACD. All right, so this AC is the hypotenuse and this is opposite side. I use sine 60, which is the opposite side, which is AD, over hypotenuse AC. Again, I change subject to AC, so that would be AC sine 60. So do it step by step. All right, and then AC times, what is sine 30? Sine 60 is root 3 over 2, and then equals to AD. And then now I change subject to AC and move this to the right hand side. I need to flip over in this way. Okay, so therefore I have AC also in terms of AD and AB in terms of AD. Now I can simply find the ratio of AB to AC is equal to 2AD to 2 root 3 AD. Okay, so they are all in terms of AD, so that I can ignore AD, and then therefore I get this 2 to 2 root 3. Okay, and then I put them for the same denominator. Okay, and this will be 2 root 3, right? Root 3 and root 3 cancel out, so I get 2 here, and no change. Therefore, they are all here is on root 3 and root 3. I can ignore this root 3, so I will get 2 root 3 to 2. Finally, 2 and 2 cancel out. The final answer is root 3 to 1. Okay, so this is how we do part A. What is part A? To find the ratio of AB to AC. So we need to link them up using the common side, which is AD, and then you change subject to AB in terms of AD, and then also AC in terms of AD, and then this is the way that we find the solution in part A in this question. Okay, now part B, we are given AB is equal to 12 root 3, and now we have to find the length of AC. Here is the diagram to enlarge it. We are given this AB is 12 root 3, so I can put this is 12 root 3 in meter, and now we have to find the unknown, which is AC. Okay, so how do we find that? Just now we have worked out the ratio for AB to AC, which is root 3 to 1. So we start with that, saying AB to AC is equal to root 3 to 1. Is that right? Now, what do we know already? We know AB. Okay, I just substitute. AB is 12 root 3 to AC. We don't know, which is root 3 to 1. Okay, remember, ratio is exactly same as fraction. So that is 2 root 3 to AC is equal to root 3 over 1. Okay, now I can find AC in this way. To do cross multiplication, I have root 3. AC is equal to 12 root 3. Therefore, AC is equal to 12 root 3, and move this root 3 to the right hand side. Okay, root 3 cancel out. Therefore, answer for AC is 12. Okay, so you can make your conclusion and saying that therefore the length of AC is equal to 12 meters in this way. Okay, so that's all about today's chapter, special angles. To remind you one more time, this table is very, very important, and then you have to memorize all this value for this special angles. Okay, so thank you for watching my video. I'll see you next time. Bye bye.